We're now going to study additional properties of functions that are related to derivatives of the function. And the first property that was also the first property that was studied in standard calculus is going to be the following theorem. So theorem number one. Suppose that f has a maximum, in fact, local maximum, or a local minimum at some x equal to a, and also let's suppose that f is differentiable at a. Then what is the conclusion, right? As we all know, again, derivative represents the slope of a tangent line. So if you have a differentiable function, then at the maximum or minimum, the tangent line should be horizontal. And so derivative of f at the point of a maximum or a minimum must be equal to 0. So therefore, f prime of a should be equal to 0. And let's see how we can prove this. So we're going to try to prove this statement by using a contradiction. And I'm going to prove only the case of a local maximum, because the case of a local minimum can be either proved in a very similar way, or instead of considering a function f, you can consider a function minus f. If f has a maximum, that minus f is going to have a minimum at the same point. And then if a derivative of minus f is 0, then derivative of f must be 0. Okay, so let's suppose that f has a local maximum at x equal to a. Now, before doing anything, let's recall what that means. If f has a local maximum at x equal to a, then that is the same thing as saying that f of x is going to be greater or equal than f of a. Well, maximum actually means the opposite, not greater or equal, but less or equal than f of a, for all x in the interval, let's say a minus epsilon, a plus epsilon, where epsilon is greater than 0. So epsilon can be any number, some small number, some small positive number. So the function is going to have a local maximum at a certain point if it actually has a maximum at a in the vicinity of a. Okay, so let now also suppose suppose also that f is differentiable at a, and that f prime of a, let's say, is greater than 0. And what we want to do is that we want to show that we're going to get a contradiction this way. Okay, so, all right, so then if this is true, now what is f prime of a? So we have 0 less than f prime of a. What is f prime of a? That's a limit. X goes to a of f of x minus f of a divided by x minus a. All right, and that is fine. But then also, from a definition of limit, we know that the limit of the function, we know that the limit exists as long as the limit from the right exists, limit from the left exists, and both of those limits are the same. So I can just add here limit x goes to a plus of f of x minus f of a, x minus a. Same thing as a limit x goes to a minus f of x minus f of a over x minus a. All those things are going to be the same. Okay, so I'm going to take a look at the limit from the right. So let's consider so what am I going to get from here? I'm going to get that limit x goes to a, f of x, a plus, f of x minus f of a over x minus a. This is f prime of a, and this is in turn greater than 0. Now, what can I say about this? Because the limit exists, I can now try to use the epsilon delta definition of the limit. So what this means is that if I pick an epsilon, let's say to be f prime of a over 2, then I only should be able to find the corresponding delta, etc., that is going to ensure that the function is minus the limit is going to be less than delta, less than epsilon. So what am I trying to say by definition of the limit? Of a function. There exists a delta greater than 0 such that if x minus a is less than delta, and because I'm taking a limit from the right and x is greater than a, then the value of the function minus the limit is going to be less than epsilon, and as a epsilon I chose f prime of a over 2. So then f of x minus f of a over x minus a minus f prime of a, this is less than epsilon again, which I in this case decided to use f prime of a over 2 as maximum because f prime of a over 2 is a positive number. All right, so this means, or this is equivalent to, saying that if x minus a is less than delta and x is greater than a, and I can drop the absolute value sign to rewrite this as the difference is less than f prime of a over 2, and it is greater than minus f prime of a over 2.